Let's do the first problem on the vector conversion worksheet, which is right here. Show it to you. So let me see if I can get the whole thing. Yeah, I think the whole thing is on the screen right there. And so what you're going to do in this worksheet is that these problems right here, I give you the magnitude, or how long the vector is, and its angle as measured from the positive x-axis. In other words, I give you the vector in polar coordinates. You're going to have to give me the x and y components of these vectors. And then in these problems here, notice I give you the x and y components. And given the x and y components, you'll have to figure out the magnitude of the vector and the angle. So here we're going from polar to rectangular. And then here, we're going from rectangular coordinates to polar. Well, let's do problem number 1. We're given a vector that is at an angle of 25 degrees and has a length of 20. And I went ahead and drew a picture of it on the first 2 problems. But in the remaining problems, you'll have to draw the picture yourself. And it does say to draw a sketch of the vector. So, number 1, here's what's given. This is 20 meters. And this is 25 degrees. And we want to find Rx and Ry, or the x and y components of this vector. So let's solve it. Now, I'm going to go into a little bit more work than I normally would do, but remember that the definition of the cosine of an angle is the x component, which we call Rx, divided by the hypotenuse, which we're just going to call R. Okay. Well, let's draw those components. Here's vector R, which is 20 meters, but here's its x component. And here is its y component. Well, R in the y, we'll call this R in the x. Now, why do we call it R? Because I didn't give it another name. I mean, if you notice in the other vectors here, I say it's vector C, vector D, vector E, F, and so on. Or over here, I don't even bother with that. Give it whatever name you want. You can just call it vector R each time if you want to. Well, that means that R in the x is equal to, well, multiply both sides by R, and you get R cosine theta. And from now on, that's where I'm going to start. I'm not going to bother with the definition of cosine. I'm just going to go to this, just because it's a little less work. So R in the x direction is going to be equal to R, that's the 20 meters, times the cosine of the 25 degree angle. And I get a calculator. Make sure your calculator is in degrees. If you don't know how to do that, come talk to me. I'll show you how to change over your calculator. If you're in AM or AMA, quite often you're moving your calculator back and forth from radians to degrees. So here's a calculator. Let's see, 20 times the cosine of 25 degrees. And that's equal to 18.126. I'll just round it off to 18.1. So that's R in the x. And then R in the y is equal to, well, 20 meters times the sine of the angle. So we'll go 20 meters times the sine of 25 degrees. And you get 8.45 meters. So this vector R is equal to, well, usually we put the x component first and the y component second. Kind of like an ordered pair from your math days, right? So this is your vector R. We are finished. We have converted it from polar coordinates, which is a magnitude and an angle, to, well, look, this goes over 18.1, and this goes up 8.45. And that defines the vector. That's all the information you need to understand what vector R is. Okay? Any questions? Okay. That is all.